In this video, I will provide a quick introduction to tree graphs. So in graph theory, a tree is a connected graph with no cycles. Now, a connected graph just means that you can get from any vertex to any other vertex in the graph just by traveling along a sequence of edges. And a cycle is when we have several vertices, maybe like this, that form a closed loop. So a tree graph has no cycles. It cannot have this structure. Now, there are a couple interesting properties about trees. The first is that if a tree has n vertices, then it has exactly n minus 1 edges. So for example, if a tree graph has 10 vertices, it must have 9 edges. The other interesting property is that there is exactly one path between any two vertices in a tree. So to illustrate these properties, let's check out this tree graph that I've created down here. So the first thing we might notice about this graph is that it is connected. So that means that if we pick any vertex in the graph, we can get to any other vertex just by traveling along a sequence of edges. And the other thing we'll notice is that there are no cycles in the graph. So there are no closed loops at any point in the graph. And we can also verify that this graph has both of these properties right here. So the first property is that if the tree has n vertices, it must have n minus 1 edges. So if we count the total number of vertices, or sometimes they're called nodes, we'll find that this graph has 10 total vertices. And we'll also find that if we count the total number of edges in this graph, there are 9 total edges, which is indeed one less than the total number of vertices. And we can also observe that this property right here is true. So there's only one path between any two vertices in a tree. So for example, let's say you wanted to go from this vertex to this vertex. There's only one possible path that you could take to get there. And it's this path right here where we cross this edge, then this edge, and then this edge. This is the only way to get between those two vertices. Or as another example, let's say we want to go from this vertex all the way to this vertex. There's only one possible path that you could take, and it's this path right here. This is the only way to get between those two vertices. So that's true of any pair of vertices in the graph. Now, in the real world, it turns out that these types of tree graphs actually appear quite often. So a couple examples are a family tree, where you can imagine that a parent is one node, and then extending from them is a child, and then a grandchild, and then so on and so forth. Or another common example would be an org chart for a company. So if you have maybe, let's say, a boss, and then reporting to that boss is, let's say, a manager and another manager, and then reporting to each of those managers are some employees. Maybe it looks something like this. So these types of tree graphs actually appear quite often in different scenarios in the real world. So this was just a quick introduction to tree graphs and a couple of their interesting properties.